Chapter 1, Statistics, Data, and Statistical Thinking. For Part 1, we'll be discussing an overview of statistics and its basic terminology. So what is statistics? Statistics is the science of data. It involves collecting, classifying, summarizing, organizing, analyzing, presenting, and interpreting data. Data just being another word for information. In other words, statistics is the study of how we interpret information and communicate that information to other people. Today, information is literally at your fingertips. If I ask you a question, you can give me the answer in a few seconds just by looking it up on a cell phone or a computer. So having a fundamental understanding of statistics is crucial to understanding the vast amount of information that is thrown at you on a daily basis on the news, in commercials, on the internet, etc. So a collection of data is called a data set. When we talk about a data set, there's two kinds. There's a population and a sample. A population is a set of units, usually people, events, or objects, that we are interested in studying. In other words, it's all the people or all the things that we are interested in studying. A sample is a subset of that population, and the key idea here is that a sample is usually smaller than the population, and we're not truly interested in just those people or just those things that we sampled, but we're going to use that information to get an idea about the bigger group. So types of statistical applications. There are two main branches in statistics, descriptive statistics and inferential statistics. Descriptive statistics utilizes numerical and graphical methods to look for patterns in a dataset, to summarize the information revealed in a dataset, and to present that information in some convenient form. In other words, it describes a dataset. Inferential statistics, on the other hand, utilizes sample data to make some estimates, decisions, predictions, and other generalizations about the population. So just to give you an outline of what the course is going to be set up like, we're going to be talking about things in 4 different distinct groups. Part 1, which is Chapter 1 in your textbook, will introduce the basic vocabulary for the course and provide a general overview of what the field of statistics is all about. Part 2, Chapter 2, will cover some basic descriptive statistical techniques. Many of this you're already familiar with, such as pie charts and bar graphs and averages, maybe mean, median, and mode. But other things that you may not be so familiar with, like standard deviation or box plots, or things that you just may not have seen so much unless you've studied statistics before. For Part 3, which is going to be Chapters 3 and 4 in your textbook, we will explore the field of probability. Probability is a mathematical field. It's not specifically part of statistics. However, it is going to allow us to go from just describing a sample to use this math of probability to make inferences about the population, which is Chapters 5, 6, and 9, inferential statistics. This is really exciting, being able to take a piece of sample information and from that make some conclusion about a much bigger group of people. It really is the most exciting part of the class. So just a little more vocabulary. An experimental unit is an object, which again could be a person, thing, transaction, event, or really anything, about which we are collecting the data. So if we have a sample of 50 people, the experimental unit would be a person. A variable, on the other hand, is a property or characteristic of an individual experimental unit. Essentially, if you're asking somebody what's your favorite color, the variable would be favorite color. It is the answer to a question. So let's go through some examples on using vocabulary. Suppose I want to know the average age of all HCC students. So that's what I am interested in. To analyze this, I decide to survey only 100 students and ask them their age. The average age of those 100 students sampled was 26.8 years old. So the question is, what is the population? What is the sample? What is the experimental unit? And what is the variable? Let's see if we can pick these out. So starting off with population, we know the population is all the things or objects or people that I'm interested in. Since I'm interested in all HCC students, it says so in the first sentence, that would be my population. So for the next set, we want to find the sample. The sample is actually the people that we looked at. So we looked at 100 HCC students, so that would be our sample. the 100 HCC students surveyed. All right, the next part is usually the trickiest. It's what is the experimental unit? So this is the actual person, the actual thing, the actual whatever that you looked at. The easiest way to find it is to look here where it says, I survey 100 HCC students. Well, since we looked at 100 HCC students, an HCC student must be the experimental unit. Most students find it pretty easy to identify the sample size. We have 100 of something. That's our sample size. So whatever words come after the sample size is usually your experimental unit. A variable is what we actually ask the students what we're measuring. We're measuring their age, so that is the variable. All right, a little more vocabulary here. A statistic is a number that describes a sample characteristic, like a sample average. A parameter, on the other hand, is a number that describes a population characteristic, like a population average. So a statistic and parameter are very similar. The only real difference is a statistic comes from a sample, S for sample, S for statistic, and a parameter comes from a population, P in both. Continuing on, going back to our previous example, we saw that the average age was reported to be 26.8 years old. Is that 26.8 a statistic or is it a parameter? Well, remember, we looked at a sample, and this was a sample average that was 26.8 years. So therefore, it must be a statistic because it's coming from a sample. Regarding statistical inference, a statistical inference is an estimate or prediction about a population parameter based on sample statistics. We'll explore more on this when we get to Chapter 5. But one thing I want to make a comment on is that when we do make statistical inferences, one thing to keep in the back of your mind is that they must accompany a measure of reliability. You must include one. In other words, how certain are you of your answer? It's fine to say that we think the average age of HCC students is over maybe 26 years old, but how certain are we of that? So maybe I think there's only a 5% chance I'm wrong or a 10% chance I'm wrong, but there is going to be a certain chance I'm wrong, and I want to inform my reader of that, or else I'm just being dishonest. Including a measure of reliability is what separates a statistician from a fortune teller. Regarding types of data, data can either be quantitative or qualitative. Notice that quantitative starts with quant, like quantity, and qualitative starts with qual, like quality. So quantitative data is just that. It's data that's on a numerical scale, a natural numerical scale. It includes measurements and counts, measures of quantities. Qualitative data are measurements that cannot be measured on a natural numerical scale. They can only be classified in groups. In other words, if I decide to assign like the color red equal to 1 and orange equal to 2, those aren't natural numerical scales. So even though they are numbers, they're not truly acting like numbers. They're really just categories. So that would be qualitative. So let's go through an exercise. So for the following, let's identify the following as either quantitative or qualitative. Quantitative, just for a shortcut, we'll call QN, and qualitative we'll call QL. So let's discuss major. Would major, if I asked a student, what is your major, would that be quantitative or qualitative? Well, thinking about a student's answer, they're going to answer something like business or maybe accounting if they're being specific, or math or science or biology. They would answer words, and being that these are words, this has to be qualitative because it's categorical in nature. Now going to age. Age is numbers, right? Like maybe I'm 40 years old or 20 years old. These are age. It's measured in years. It's counting the number of years. This is clearly quantitative. It's numerical in nature. Okay, what about weight? Well, similarly, weight would be also quantitative because, again, it's on a natural numerical scale. Eye color. Eye color can be green or blue or brown, but these are not numbers, so therefore it would be qualitative because it's categorical. Temperature. Temperature, again, is on a numerical scale, like 10 degrees, 20 degrees. So this should be quantitative.